So we're looking at problem number 17. Yeah, for completeness, we'll do both parts.
It's going to be on headline.
Uh-huh.
Oh, it says 19. That's what I thought.
Yeah, I really wanted, I guess, 19 and beyond, but we'll do 17 anyway.
I'm not really 16.
What is the acceleration of two falling skydivers when the upward force of air resistance is equal to 1/4 of their weight? So what did you do with this?
I'm sure.
He drew a free body diagram. Yes, this is the right answer. And here are my two skydivers. And what forces do you show in your free body diagram?
Air resistance?
Wait.
Yep. And then 1/4 of that, 1/4 of mg going up. Good. And keep going.
And I said that some forces and
Uh-huh.
said that was 1/4 of that minus, so like negative 0.75.
Interesting that you have negative here, so that means that in your reference frame, this is up and that's down, which is cool. It's pretty clear we're going to get a negative value for the acceleration then,
Negatives.
and that works out exactly. Notice that the actual numbers for their weight are irrelevant to the problem. Okay. Now in part B, we are told that after popping open the parachute, the divers descend leisurely to the ground at constant speed. What now is the force of air resistance on the skydivers and their parachute? All right, and what'd you do with this?
I wasn't really sure what. It's like constant speed, so they don't have any acceleration, so that's just zero. That was confusing.
So here we have an example of somebody who's mentally trying to juggle too many things at once. Does everybody hear his confusion? And he's got a problem, he doesn't know what to do with it. And the reason that I say he's trying to juggle too many things at once is that the method he used for part A would work just fine for part B if only he would do it. But he doesn't do it. He has a block against doing it because he doesn't see how it's going to work out at the end. And I say, even if you can't see how it's going to work out at the end, still in all, work the process. Trust the process to give you insight. That's the key message here. So you told me to start with a free body diagram. Gosh darn it, start with a free body diagram.
Okay. So same mg's down. I guess just like force of inertia.
Good.
Two forces. Parachute force times
Equals 0.
I guess, yeah, that's the part that confuses. It's like 0. Just because it's
Is it like 0 or is it 0?
0.
Well, if it is 0, then gosh darn it,
It's 0.
it is 0. Now, algebraically, what does that tell you?
There's
And you're done. The end.
Geez, so theoretically, if they wanted an answer, you
They got an answer. It's MG. MG is 130 chickens. No, it can't be.
It's about 102 kilograms.
Yeah, so 1320. So what happened here? Well, the only difference between me and you, we actually know the same things to do for this problem. And the only difference is that I've been around the block enough to know that the process really works. So, work the process. And let the process give you some insight. Don't try to juggle all of those things in your head mentally to make them come out. It's nice if you can do that. You can see the end from the beginning. That's when you feel really brilliant. But if you can't, then say to yourself, I know I can do free body diagrams and set sum of forces equal to mass times acceleration. Let me at least do that.
Yeah, that also confused me, because if their forces were equal, like why would they slow down? Why wouldn't they just stop?
Great question.
Because I kind of thought that could be the answer, and I was like, no, that'd be weird.
Great question. And we're about to have some learning here. Tell him.
But because it's acceleration to velocity, you're already falling down.
Bingo. Galileo, not Aristotle, was correct. The sum of forces is not mass times velocity. It is mass times acceleration, the rate of change of velocity.
Where'd you get the 0.75?
1.1.
Yeah, so you have here, sum of forces is 1/4 mg minus mg, so that would be negative 3/4 mg, or negative 0.75 mg. Does that make sense, algebra-wise? Good. Other questions about homework problems?
I didn't do it. Try 32.
You can try 30. Okay, so we have a pair of fuzzy dice hanging by a string from your rear view mirror. And it's hanging at a vertical angle of theta. And it says, while you are accelerating, from 0 to 28 meters per second, about how many miles per hour is that? About 60. Really to 60, it's about 65. In 6 seconds. What angle theta does the, do the dice make with the vertical? Here are the dice right here. That's all it tells us. They also give us a little bit more.
Because the free body.
They don't exactly. They give us something that looks like a free body diagram, but it's not a free body diagram because it has acceleration on it as well. So our pure, true free body diagram looks like this. Now what? I think finding the acceleration is a good idea. Go. I'm probably going to want an equation. because I roll like that.
Delta V over delta V
Equals,
equals A.
thank you. Equations always have an equal sign.
Equals 6.
Yep. 28.0 meters per second. Divided by 6.0 seconds, which equals
4.8.
4.4. 4.4 watts. Okay. Now all those niggling little details that I had to milk out of you, deliver those routinely. Okay? Equation, plug in, solve. Is it 4.6? Yeah, you're right. So it would not be 4.6, but 4. It would be 4.7. Two significant figures. I think we've got that. Good. Now, yeah, we're going to have to do some reports. It's good. So this presents a unique obstacle. Why is adding up these forces going to be a little bit challenging for us? Because there's a cosine. Well, there isn't yet, but there's going to be. And why is there going to be a cosine?
Because
How many dimensions is this problem operating in? 2. That's exactly it.
Three-dimensional forces.
No, but 3D forces don't add a whole lot of extra complexity, really.
Why is acceleration going that way?
Because the car is going that way?
Oh,
Thanks. Oh, for me?
Yep.
Andy. And Priscilla.
No, that's what I had to go back to.
Delivering your own paths. That'd be great.
3 minutes.
Yeah. Are you 99% sure? I'm going to go back to that.
Okay. Okay, yes, so we're in 2 dimensions, so we're going to need components here for our forces. So explain how that happens.
Sum of forces equals that times acceleration.
Certainly, but
It's not acceleration. Staying still.
okay, that's fine.
Yes. Would you need to find cosine of angle theta equals what's it, 50 or something like that?
Or something like that. Okay, you kind of ground it out. Somebody help me out here, because this process, very basic process, and it has to happen. Yes.
You put the brake gravity into energy sine theta and energy cosine theta.
That could work.
Like tilt it so that friction is up.
Yeah. I don't like the tilting part because the acceleration is straight across. I'm thinking.
split up FT into 2 components?
I'm thinking FT is the one that wants to go into components because it's the odd man out with respect to our axis.
How's the other two? Right?
The other 2 are right. That's exactly right. So FT is the one that needs to go into components. So then the next question is, how does that happen?
What's the answer to A? What's A?
We don't know yet.
Yeah, we solved it.
Oh, the acceleration is 4.7 meters per second squared. So on your diagram, Andrew and others, you're going to scratch out the original FT and replace it with its two components. Now, here's the slightly tricky part. You see that angle right there? I look at this angle, and I see that this angle is not in its usual location, which is right here. Instead, it's being measured from the vertical. And so I ask myself, how does that change things? And I observe that the angle theta is opposite to the FTX. The opposite component is always, 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 without exception, the sine component, because sine is opposite over hypotenuse. So we have a reversal of the usual. FTX is actually FT cosine theta, excuse me, sine theta.
Why?
Wait, it is such an ingrained habit with me that when I try to break it, sometimes I fail. And so we have that. All right? Okay. Now that we have the components, we're ready for...
The sine forces.
Yep, go ahead.
Forces equals mass versus acceleration.
But in which direction?
And
True. So, therefore, we're going to do that separately. Okay. And then give me the sum of forces in the x direction.
ft sine theta.
Why?
Because it's the x direction, that's the direction the car is traveling. So wait, wouldn't it be negative?
Give me Newton's second law again.
Some forces equals mass times acceleration.
Yeah.
Traveling in the x direction.
Okay. So look at this very carefully here. You just told me.
Mass.
Right.
Whoops.
Yeah.
What's the data Z?
What is mass?
We don't know.
X.
So MG.
M,
So just
M,
Yeah,
M.
that's right.
M.
So we'll call this A. Now we have a value for A. We know that, but we're going to hold off on that. Okay. All right. How about in the Y direction?
It's STY. I'm sorry, ST cosine theta.
Mm-hmm.
That's M.
That's true. I don't want you skipping steps here. I want you to do the legitimate sum of forces here. According to the diagram, what is the actual sum of forces?
Mg equals MG. No.
According to the diagram, what is the actual sum of forces here?
Mg.
No.
0.
No.
MA.
According to the diagram, what does the diagram tell you that the sum
Y minus mg.
Yes, that's right. It's a simple matter of reading the diagram.
How?
Forces that go up are positive, forces that go down are negative. That is your sum of forces, and it is always read from the diagram. It is never done by guessing or second guessing the problem, trying to be clever with the problem. You just look at the diagram and you go, what are the forces the diagram tells me are there? And you put those dutifully in your sum of forces. That's the point of the free body
That's
diagram.
equal to MA.
This is now equal to MA in the y direction, which is 0 in the y direction, because the fuzzy dice and the car are accelerating in the x direction and not
I
the
knew
y
that.
direction.
0.
The only car that accelerates in the y direction is Chitty Chitty Bang Bang.
That's the ability.
With a really annoying song.
And now that's
Really annoying movie.
Okay. And now what we're looking for is FT. And here's where we want to do, I'm going to give you some professional advice on this guy. We've got FT sine theta equals MA. And this equation gives us that FT cosine theta equals mg. Now, this means that your intuition was correct, right? We just want to get there carefully. We're not going to rely on just our intuition. And so we're trying to solve for theta, And now I'm going to pull off an elimination trick
Oh,
here.
yeah, I just saw that.
We have a value for A, of course we have a value for B. And we are going to now eliminate ft out of our equation, not by subtracting, but by dividing one equation by the other. This is the algebraic trick that you see it once and you go, ooh, who would have thought of that? And you see it a second time and you go, oh, I could probably do that. You divide one equation by the other and a whole bunch of stuff cancels out. My ft's cancel out, and the m's cancel out too, so that the fuzzy dice mass does not matter for the problem. And I get sine theta over cosine theta is equal to 4.7 over 10, or 0.47 there, with no units because the meters per second squared cancel out. Exactly. Sine theta over cosine theta is the same as tangent, and therefore we have our m. That's it. You got it. And when you do, then you should get an angle of somewhere around 30 degrees.
Okay,
Mm-hmm.
so
Was that 23.9? 43.9? Seems larger than I was expecting.
I just did inverse tangent of 47.
43.9.
Almost like
Okay.
calculators.
No?
Why?
That does seem larger than I was expecting. I'm just going to check that real fast. I'm taking a tangent of 43.9 degrees.
Just one would be 45.
Yeah, exactly.
That's the number.
Right. No, that's 0.96.
Tangent 0.47.
I got 25.2 degrees.
0.43, and you now my calculator lies to me.
I did put 47.
That makes much more sense.
I have to do
Yep.
It was radius. It was.
The radiant should be getting this one right here. Oh, it's 0.439, and instead of paying attention to that, you just kind of threw the decimal point wherever you wanted to. Don't do
I
that.
thought I said 49.
Don't do that.
so it's equal to, and we learned to find the angle.
All right. Are there any other remaining questions about problems that you worked last time?